Okay, Assalamualaikum and a very good day to all. So we are going to continue to our last chapter, which is thermodynamics. Okay, so we are going to separate into first and second part. So the first part we only discuss about introduction to thermodynamics, store energy, first law of thermodynamics, and for the second part going to be for this one. Okay, for the first part, mostly you already learned in chemistry. Okay, they are going to be a slightly different in terms of the equation itself, but basically you can actually use both chemistry or physics to answer the questions. Okay, so let's start. Okay, so basically before we go with the internal energy, now we need to understand that we have different kind of energy. We have internal energy. So basically internal energy is about energy in terms of that molecule itself. Okay, so internal energy is the combinations of the kinetic and also the potential energy. Okay, and then we have a chemical energy, which is basically something about the food is burned or the food is consumed, so that's what we call as a chemical energy. Okay, we have sensible energy, which is basically is one of the we call as the internal energy, which is associated with the kinetic energy of the molecule itself. And then we have the latent energy, which this one very familiar because in chemistry, which is associated with the change of phase of the system. Okay, this kind of a latent energy. Okay. Okay, but here we only discuss about kinetic and potential and the word done only. Okay, so we are going to start with the first one, which we call as a potential energy. Okay, so when we have a potential energy, it's all about height. Okay, it's all about height, and the potential energy is mostly affected by gravitational potential energy. Okay, so the one that you call before, we not call as PE, we call as a U. Potential energy is basically something that relate with the height. So we have potential energy equals to mglh over gc, and please take note for the potential energy and kinetic energy you need to use the gl and the gh. Okay, so the potential energy here also depends on the unit itself. So we have a SI unit, we have a USCS system, and we have the engineering system. Okay, for the value of gc here is basically the same thing that you use for the SI unit, where you need to use 1.0 kilogram meter per second square over Newton for the SI unit. And the for USCS system, we are going to use the 1.0 slug feet per second over pound. And the engineering system, we are going to use 32.1740 pound mass feet per second over pound force. Okay, so the GL over there, the GC over here, you are going to use all these three things, and the GL is basically depends on the SI, USCS, and engineering system. Okay, so as I mentioned before, the potential energy is about height. Okay, so we have one reference point. Example, okay, this one we call as a reference point, which means at the starting point for you to choose, because the potential energy is about U equals to mgl height final minus height initial divided by GC. Okay, this one also we can actually put it as a Y final or Y initial. Y means that because it's height, mostly we talk about in Y axis. Okay, that's the reason I changed to Y. Okay, so the reference point here we also call as a datum. Okay, so then another name for the reference point is a datum. So you are going to take your height from datum up until the height that you want to find. Okay, so example, if you have 2 meter here, so means that this one going to be 2 and the initial height going to be 0. So basically what happened here is your reference point going to be 0, and the height that you need to find the potential energy going to be your final height. Okay, so the unit for the potential energy, it can be a Newton meter, okay, or it can be pound force feet. Okay, so potential energy is about height. Okay, or the other name that mostly familiar we call as a joule. Okay. So when it comes to the kinetic energy, it's different from the potential energy. Kinetic energy is about movement. Okay, you have kinetic energy, which is half mv square over gc. Gc is also the same thing that I mentioned before. You need to use 1.0 for the SI unit and also for the USCS system, and 32.1740 for the engineering system. Okay, for the kinetic energy, we don't have a datum. It's basically something that movement. If the object is moved from one distance to another distance, then means that the kinetic energy applies there. Okay, so the kinetic energy here, also the unit is Newton meter and also feet pound force. Okay, so here how to get this kinetic energy is not just like that. Basically, for you to get the kinetic energy, I think you remember how to use this formula from the SPM, where you use S equals to ut plus half AP square. Okay, so basically what happened here is we have work done, force time distance, and force is basically ma distance. Okay, and then for you to get the value of a, we are not going to use this formula. We are going to use another formula, which is the formula is v square equals to u square plus 2as. As here, I'm going to change into d. Okay, so basically what happened is your initial, this is your this is your reference. The initial going to be your reference and the final going to be a final position. So what happened is you put a as your subject, so you are going to get v squared minus u squared over 2d. Okay, so you just put it into this formula, so you are going to get work done equals to m v squared minus u squared over 2d multiply with the d. And that's the reason you are going to get the formula for half mv squared final, which is this final, minus half mv squared initial square. Okay, yes. Okay, so we're done here. We change into k. That's how you get the formula for kinetic energy, which is something that move. Okay. Okay, so basically, the kinetic energy and potential energy is one of the work done. Okay, you need to understand when it comes to the work done is force time distance. Okay, so what happened here is we have cos theta here, which means that the angle theta is basically between D and F. Okay, so if you move, okay, you have one object and then you have force here. Okay, and then it move with some distance. Okay, because both move in the same direction, so the angle theta going to be 0. Okay, what happened if you have friction here? Okay, your D here going to be your reference point, so the angle going to be taken from D up until the force that you want to find. So now I want to find the work done by frictional force. So what I need to do is I need to take from D up until here, which is going to be 180 degree. So work done by frictional force going to be FFR times with the D cos 180 degree, which means that you are going to get negative joule, which means that is basically correct because friction's going to cause you loss of energy. You are going to be so tired when you have a friction, and that's the reason why you get negative here. Negative doesn't means left, doesn't means downward. Because work done, energy, potential energy, kinetic energy is scalar. It doesn't depend on direction. It depends only on the magnitude. Okay, that's how you do it. Okay, example, if you have one object, okay, and then you have force like this. Okay, when it comes to have this kind of force, definitely is going to be a vector where you need to resolve for this one. Okay, so you have here, example, this is angle F cos theta, and then you have here is the F sine theta. Okay, which one that going to have work? F cos theta or F sine theta? Okay, example, if moving in this direction. Okay, the only thing that going to cause you work is going to be F cos theta because of what? Cos 0 degree, because moving in the same direction. Okay, for the F sine theta, is there any work done? No. Why? Because if you extend this a little bit, you are going to find it, this is going to be 90 degree. This one going to be 90 degree, which means that if you put W equals to FD cos theta, so the F here going to be F sine theta, FD cos theta, theta here going to be 90 degree, which means that there will be no work done at the F sine theta. Okay, so example here, okay, I'm saying the example, this is angle 20 degrees. So the way you need to write it first, the only one that have a work done is F cos theta. So when you put W F, which is the force applied, F cos theta, example, this is 20 Newton. So it's going to be 20 cos 20 degree first. This is F cos theta. Okay, multiply with the D, example moving with 2 meter. Okay, and then you need to put cos here. Cos theta here is basically the difference between the F that you need to find and the D. So it's going to be what? 0 degree. And then you get the answer in joule or Newton meter. Okay, so cos theta here is basically to represent the difference between D and F. Okay, so your D going to be your reference point, and you need to find the force, and then you need to take your angle from the D up until force that you need to find. Example, if the frictional force, then it's going to be 180 degree. That's how you do it for the work done. Okay, here I already mentioned that when it comes to work done, when you have force acting to a distance, then we will call as a work done. If example, you have a force but you're not moving with a distance, then you don't have any work done. Okay, that's how you do it. So this is basically the example of the work done to raising the piston, to rotating the shaft. We call as a work done. Okay. 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 So here is basically a very simple questions for you. To use the equation that I mentioned before. So example for the question 1, a boulder with a mass 1.15 times 10 kilogram rests on the ledge 3.20.5 meter above the sea level. Okay, so when it comes to the above sea level, is related with high. So when related with high, what energy that we need to find? Definitely is going to be potential energy. Okay, potential energy. And what is the magnitude? So based on the formula itself, is going to be U equals to mglh over gc. So your mass is going to be 1.151 times 10 power of 3 kilogram time. Okay, because it's set in meter, which is definitely in SI unit. So it's going to be 8.70 meter per second square. And how about the height? 320.5 times 320.5. So divide by the GL going to be 1.0 kilogram meter per second square over Newton. Then you get the answer. Okay. Okay. For the question 2, okay, a 2.3 power of 4 pound mass semi-trailer is traveling at the sea level at the speed of 50 miles per hour. So definitely when it comes to 50 miles per hour, you need to change first into meter per second. So use the conversion unit. Determine the energy form. Okay, so when you have something that actually moving with the speed, definitely is going to be kinetic energy. Okay, and the magnitude possessed by the truck, express the magnitude in engineering system unit. Okay, so basically when it comes to miles per hour, it's not the engineering system. You don't have to change into meter per second. What you need to change into is feet per seconds. Okay. Okay, and then, okay, the questions, okay, the formula is going to be K equals to half mv square over gc. So m here is going to be this value, okay, 2.43 power of 4. And the v square here, you need to change first to feet per seconds, okay. And the gc here, because the question asks you in engineering system unit, definitely you are going to use 32.1740 pound mass feet per second square over pound force, and then you are going to get this answer. Okay, so the next question, okay, the next question, a force of 2 power of 2 Newton 18 at the angle of 30 degree with the horizontal is required to move block A along the horizontal surface. How much work is done if the block is moved 2.50 power of 2 meter? So the question asks you about how much work is done. So means that the formula that you need to use is going to be W equals to force times distance cos theta. Okay, so force here, because it's acting at the angle 30 degree, which means that you have a block, and then it's acting like this 30 degree. This is your force. So this is going to be, this is going to be F sine theta. This is going to be your F cos theta. So definitely the one that going to produce a work done is this one, because D is moving in the same direction. Okay, so you have here is going to be 2 power of 2 Newton sine 30 degree. You multiply with the D is 2.50 power of 2, and then the cos theta here going to be, because it's moved in the same direction, 0 degree. Then you are going to get the answer, which is 43.3 power of 3 Newton meter or joule. Okay, so it's very easy for this. For your level, the question is going to be like directly the question direct, which means, but you need to detect first the energy itself. Okay, what type of energy, whether it's potential or kinetic, and how to get the formula and how to use the formula. Okay. Okay, let's proceed to the next one. Okay, so now we are going to talk about energy transfer by the heat. Okay, heat is basically one of the form of the energy. Okay, for the energy itself, for the work done, is going to be transferred from one system to another system, because based on the law, energy cannot be created, cannot be destroyed. So energy can be changed into the other form of energy. So heat is one of the form of the energy, but heat need to transfer the energy, but they need to have this one, which is called as a temperature difference. Okay, if you don't have any temperature difference, it means that heat cannot be transferred. Okay. Okay, before we proceed with the what we call as internal energy, you need to understand all this term first, because this is going to be in your second part. But here, because this one going to be repeated like almost all the time, and then you need to understand the meaning of all these terms. Okay, when it comes to the cyclic process, it means that you given the initial state, and then you're going through the various process, and it's going finally return to its original state or initial state. Then we call it a cyclic process. So mostly for our calculations for the second part going to be cyclic process. But the difference going to be here, reversible or irreversible process. Okay, reversible process, it means that there's no change in terms of the energy. Example, if you're going to pass through, okay, like one system, like first system, and then you go to the second system, and then you go to the third system, but the energy itself still constant, still doesn't change, then we call it the reversible process, which is the perfect process. Okay, but here, as you can see that in the real life applications, definitely you are not going to have a reversible process, because you have a like loss of energy, you have a friction, you have turbulence. That's what we call as the irreversible process. Okay, so mostly for this one is the real life application. Okay, and this one is more to like theory applications. Okay, and we are going to use mostly reversible process, which is the theory part. Okay, and then we have adiabatic process. Okay, so adiabatic process, it means that there's no heat transfer into or out of the system, or we can actually call this a perfect insulated. Okay, there's no heat into and there's no heat out of the system, so we call the adiabatic process, or perfectly insulated. Okay, so you have one system, there's no heat into, there's no heat out, so this one doesn't have, we call as adiabatic process. Okay, and then we have another terms we call as the isothermal process. Based on the name itself, thermals mean temperature. Okay, which means the isothermal process, you are going to maintain the temperature, you're going to have the constant temperature. Okay, example, if you need to change, okay, example, if your temperature is moving from higher to lower, and suddenly it's going to be higher back, but you want to maintain the lower temperature, so what you need to do is maybe you need to cool out, maybe you need to heat need to like transferred out of the system to maintain the lower temperature. Or if you need to make sure that you maintain at the high temperature, maybe at this particular time you need to add the heat. Okay, so that's the means by isothermal process. You need to do anything to make sure that the temperature is always constant and maintained throughout the system. That's why we call it as the isothermal process. Okay, so basically we have three types of law. We have Zeroth law of thermodynamics, we have first law of thermodynamics, and then we have the second law of thermodynamics. The Zeroth law of thermodynamics is everything about thermal equilibrium. Okay, so example, if you have like object A and B, and then you bring this thing close together and touch each other, so what happened is, example, if the A and B have a difference in terms of the temperature, If example A higher and B lower, so when you in contact with the A and B, it's going to cause the temperature to be transferred. It's going to cause the energy to be transferred up until there's one time where A and B have the same temperature. That's what we call as a thermal equilibrium. Okay, so it's going to stop, the heat transfer going to be stopped up until temperature is basically the same. Okay, so but if example the object A and C still have a difference in terms of the temperature, the heat going to keep transfer up until you reach the thermal equilibrium system. That's what we call as a zero law of thermodynamics. Okay, and the first law of thermodynamics is about conservation of energy. If I ask you about the first law of thermodynamics, please do not give only this answer. Please explain what does it mean by conservation of energy. So basically, conservation of energy, it means that energy cannot be created. Okay, energy cannot be created, cannot be destroyed, but it can change to other form of energy. Okay, so it can be like from like kinetic to potential, or maybe potential to heat energy or something like that. So basically what happens is energy cannot be just destroyed like that. It can change to other form of energy. That's what we call as the first law of thermodynamics. Okay, so basically we are going to use all the law in our calculations, but the first part going to be you are going to use only the first law of thermodynamics, or maybe zero law of thermodynamics also. Okay. Okay, so here I think this one you already learned in chemistry, where we have internal energy, we have work added to the system, we have work done by the system, work done on the system, we have Q added to the system, Q out of the system. Okay, so the internal energy is the combinations of all the energy inside the molecule. Okay, the internal energy, okay, here they put U as your internal energy. You can use U or you can use EINT. Okay, for the internal energy. Okay, but U here going to be the small u. Okay. Okay, so internal energy is basically the combination of all the energy. So here the energy that we are going to use is the Q, which is the heat added to the system or heat out of the system, and another one is work done, which is work done by the system or work done on the system. Okay. Okay, so okay, this one I'm going to explain further. Okay, at the back. Okay, but this one, if the system does work on the external world, means that work done by the system, to the environment, you are going to get negative work done. Okay, I know that is going to be quite confused, because in chemistry you are going to use a different value, but in engineering and physics we are going to use the same sign convention. Okay, because of, okay, here internal energy is basically the energy that going to be like constant. So what happened is it cannot be destroyed, it cannot be created. So you have internal energy here. Okay, so example, if you added heat to the system, okay, here we are. Okay, definitely there is something to decrease back the energy. Okay, if you add heat to the system, which is this positive, you are going to increase the internal energy. Okay, but as you can see, the energy cannot be energy need to be maintained. Energy cannot be like suddenly increase, suddenly decrease. Maybe there's something else to maintain back the energy. So that's the reason why we need to do some work, which means that work done by the system here is positive. So when heat added to the system minus with work done by the system means that the energy going to be maintained, and this is the formula that we are going to use. Okay, so because internal energy always be constant. Okay, and that's the reason why you have this kind of formula. You add heat, which is increase, and then work done by the system, because it's minus here, is going to cause the decrease of the energy. So what happened? This one cancel out. That's why you are going to have a constant internal energy, and this is the formula that we are going to use. If I'm not mistaken, in chemistry you are going to use UQ plus W. You can actually use this formula. There's nothing wrong with this. Okay, But here you need to be extra careful with the work done by the system and work done on the system, because it's quite different with the physics and engineering. Okay. Okay, before I go with the sign conventions, okay, here I need to explain a little bit about the force and the pressure. Okay, this is like one of the formula that we are going to use. So please make sure that you know that pressure equals to force over area, and the area is the area mostly about the pistons. Okay, so area of the piston is going to be like circle is going to be pi r square. Okay, so sometimes we are going to use this formula, but you need to take note about this formula also. Okay. Okay, so here I already said that with no change in volume of the air, heat could be added or removed, which will increase or decrease respectively the internal energy of the system in terms of the first law. So what happened is we are going to maintain the volume, but heat could be added or removed, but right now we need to have a maintain in the volume. I think this one is for isobaric, which you didn't learn, so I think this one you can actually ignore. Okay, this is like another theory, but you didn't learn this thing. You are going to learn in thermodynamics when you further your study. Okay, so this one, okay, we are going to answer the question first before we proceed with the formula with the sign convention. Okay, let the pistons move so that the volume of air is reduced to 1/2 of its original volume. During this process, 255 joule of heat is removed from the system, so definitely it's going to be Q out. If the process is isothermal, which means that you are going to maintain the temperature, and we assume an ideal gas, okay? Ideal gas, it means that there's no friction, energy is going to be constant, okay? How much work is done on the system? Okay, the question asks you how much work is done on the system. Okay, so because, okay, you need to understand when it comes to the internal energy, it depends on the temperature. Okay, why? Because temperature is going to cause the molecule itself to have a higher kinetic energy or something like that. So if you have isothermal means that you are going to maintain the temperature. So if you maintain the temperature, it means that the internal energy is going to be zero. Means that there will be no change in terms of the internal energy. Like I mentioned before, temperature going to change the kinetic energy of the system. So when you maintain the temperature, it means that there will be no change at all. So the temperature before and temperature after is going to be constant. So the internal energy not going to be any difference. That's why internal energy is going to be zero. So if you use the formula, like, okay, after this I'm going to put it U integer Q minus W. So Q is basically this one going to be Q out, okay, which is Q out is negative 255, okay, and then the internal energy going to be 0. So you are going to get, this is work done by the system, okay, so negative work equals to positive 255 joules. So you are going to get negative 255 joule, and that's the reason you're going to get negative. And negative here, based on the physics and engineering, negative here means work has been done on the system. Okay, example, if you get work done positive, it means that work done by the system is going to the sign convention is going to be a little bit different with the chemistry. Okay, you need to change. Okay, so determine the pressure of the air within the cylinder if the force on the piston is this one and the diameter is 0.3. And the answer here, they give it to you in engineering system. So means that you need to change here into feet first. You need to use pressure equals to force over area. So the area here is going to be pi r squared. So supposedly you are going to get this answer. Okay, that is going to be practically very easy question. Okay, so let's start again with the formula. Okay, so we are going to use this formula. Okay, if you want to use the internal energy equals to Q plus W, you can actually do that. But you need to change for this one. Okay, it's going to be vice versa for the chemistry part. Okay, here the Q positive going to be added to the system. Okay, and Q negative going to be lost heat, which is out of the system. Okay, and then here is positive work done. Positive work done here means work done by the system. Okay, and the negative W means work done on the system. Okay, so example, if we have like pistons and then this you have gas. Okay, so if gas do something work to the piston, is going to be work done by the system. Okay, if the pistons do some work to the gas, it means that work done on the system. So you need to identify which systems, gas or other things. Okay, so here I already mentioned that the internal energy depends only on the temperature. That's why if we have isothermal, main constant temperature, the internal energy always be 0, because you doesn't have any change in terms of temperature. Because your temperature 50 degrees Celsius and then you still maintain 50 degrees Celsius, there's no change in terms of the internal energy. Means that the molecule itself doesn't have kinetic energy, doesn't move maybe at that particular time. That's why the reason internal energy is going to be 0. Okay. Okay. This one also basically the same thing. For the internal energy is about conservation of energy. So energy goes into, definitely energy goes out. That's why you are going to maintain the energy. This is basically the system of the conservation energy. If you add it to the added heat, you added energy to the system, the internal energy going to be decreased. Okay. But you need to maintain back the energy. So you need to have something to decrease back the energy. That's what we call as conservation of energy. Same goes if you change K to potential energy. Example, if you like moving like 50 joule, you're running with the 50 joule and then you jump. So the 50 joule here going to transfer to the potential energy, because something that jumps, something that change in terms of height is potential energy. So that's what we call as the conservation energy. Okay, energy can be transformed into other form of energy, and energy is going to be constant. Okay, this is basically the conclusions of the sign convention that I'm using. Base physics engineering going to use the same thing, but if you want to use the chemistry, please be extra careful with the sign convention for the work done. Okay, it's going to be a little bit different. Okay, so we are going to practice some questions here. Okay, so we have 2,500 joule of heat is added to the system. Okay, which is Q positive, and then we have 1,800 joule of work is done on the system. So on the system, basically in physics engineering, we use negative work done. What is the change internal energy of the system? So we use here. Here they use U, capital U. You can actually use small u, or you can use internal energy, basically the same thing. But the reason why we didn't use the capital U is we didn't want to like confuse with the potential energy. Okay, so I encourage you to use small u here. Internal energy equals to change of, this is change of internal energy. So the formula going to be Q minus W. Okay, the Q here is going to be added, so it's going to be positive 2,500 joule. And then when the question state change in internal energy then on the system, sorry, it's going to be minus 1,800. That's why you are going to get 4,300 joule. Okay, pretty easy, right? Because this question you already like learned before in chemistry, but please be extra careful with the sign conventions. Okay, next. Okay, the internal energy of the system decreases by 108 joule. Okay, decreases, so we can actually see that the internal energy is negative, decreases, while 175 joule of work is done by the system. Okay, so by the system, so it's going to do some positive work. Okay, determine if heat added to or removed from the surface. If you get positive, means that you heat added to the system. If you get negative, means that it's removed from the system. So you're going to use the same formula, which means that U internal, change of U equals to Q minus W. Okay, please make sure that when you do your working steps, make sure that you write the formula, because maybe example, if your answer is wrong, maybe there are going to be some marks given to the formula. Okay, U plus W. So the question asks you to find the heat. So Q going to be change of U plus W. So the question state internal energy of the system is decreases, so it's going to be negative 0.7 plus the work done by the system. That's why I put it plus here. So it's going to be 175. Okay, so you are going to get the answer is positive 67 joule. And what does it mean? Positive here means Q added to the system. Okay, let's proceed to the next one. Okay, here a system is allowed to do amounting to 500 kilonewton meter with energy amounting to 800 kilojoule is transferred into it. Find the change of internal energy and state whether it's going to be increased or decreased. If you get internal energy negative, it means that it's going to be decreased. If you get an internal energy positive, then it's going to be increased. Okay, so okay, so heat energy transfer into it, so it means that heat energy is added to the system. Q added, positive. Okay, allowed to do amounting to, which amounting is a total to 500 kilonewton meter. Allowed to do, a system is allowed to do. When the system is allowed to do, means that work means that work done by the system, correct? So this one going to be positive, work done. Okay, find the change of internal energy. So change of internal energy equals to Q minus W. So it's going to be here is 800 minus with 500. So the answer going to be kilonewton meter or kilojoule. Okay, so this one is basically kilojoule. Okay, so you are going to get positive 300 kilonewton meter, or you can actually put as a kilojoule. So positive here means that the internal energy is increased. Okay, pretty easy. Okay, so I think that's all for now for the part 1. Okay, so after this we are going to continue to the part 2, okay, which is second law of thermodynamics, which is the applications of the second law of thermodynamics. Okay, so I see you in the part 2. Thank you very much. Assalamualaikum.